Welcome to All This Math. This is Professor Parker, and today we have a problem that was sent in by a student in Philly from Springside Chestnut Hill Academy. All right, up there in Chestnut Hill, right, past Mount Airy, right. So now we're gonna get into this word problem. So that's what the SCH stands for. I'm pretty sure. Springside Chestnut Hill. So this is a word problem. All right. Now with word problems, the first thing we always want to do is want to read the word problem, right? We have to be sound with our reading comprehension before we can even approach the mathematics or the algebra. All right. So we want to read the problem, understand the problem, make sure the problem makes sense, make sure that the information that we're given within the problem makes sense. Okay. SCH is having a carnival with $3 admission, and each game costs 25 cents. If you have $10, right? All you got is $10. Nothing more, nothing less. You got $10. Write an inequality that would help you find the possible number. It's not a hashtag all the time. In this case, it represents the word number. Number of games you can afford. Then solve the inequality. Okay? So, what I like to do with word problems, like I said, make sure you read it, make sure it makes sense to you. But what I like to do is I like to go through and like underline, kind of like with reading passages in English class or ELA class, kind of like with reading passages, underline like main ideas, key points, supporting details. That's really what we're doing with a mathematics word problem. So we got to be able to combine those skills from reading comprehension with mathematics. They should not be separate. They should be together. We gotta merge those two skills. So kind of like when you're in a math class, you got to think like you're in a reading class or in an English class or language arts. All right. So SCH is having a carnival with $3 admission. I want to underline the important information that's going to help me do my math. So this $3 admission part is going to be important. This each game costs 25 cents is going to be important. The fact that you only have $10, that's important. The fact that you're supposed to write an inequality and not an equation, but an inequality, that's important. That will help you find the possible. Now, find the possible number of games. That's important. Because the reality is, and then solve. We got to know our instructions. We got to know what our instructions are. We got to know what we're being tasked to do. Find the possible number of games. We start with understanding, like, what am I even doing here? Like, what's the point? Like, why am I reading this? Why are you watching this video? Why do you care? Because we have a goal. Our goal is to figure out what? The possible number of games you can afford. And this is real life math, right? We find ourselves in these situations all the time because this is an economics problem, really. This is an issue of limited resources and how to allocate resources. How to experience life in a certain way with limited resources. Because if you had an unlimited amount of money, then none of this would matter. Nobody would care. Because we got all the money, and if you got an unlimited amount of money, then you don't have to make decisions like this. You don't have to think critically about, well, what can I actually do with the limited resources that I have? But because in real life we have limited resources, we need to be able to do this type of mathematics and be able to think critically about how we can get the things that we need. All right. With what we have. So I want to think about first, like I need to pick a variable. All right. You always want to pick a variable. So, and we're going to pick a variable to represent what we don't know. What we don't know is the number of games you can afford. We don't know. I mean, we could guess. I mean, it could be 5 games. It could be 20 games. It could be 80 games. It could be 1 game. It could be 2 games. But when we know how to do the math, we don't got to guess. We can find out exactly how many games we can play. We can find the exact answer to our question. All right. So let's say I'm going to let G equal the number of games I can afford. And I just picked G because G is the first letter in the word game. No biggie. You can pick any variable you want, right? So G is the number of games I can afford. Okay? Now, I'm going to grab this piece of paper because it's got some notes on it. I don't want to forget anything that I was thinking about earlier when I was going over this problem. So now we want to write an inequality, right? Not an equation. So we're going to write an inequality. Now, because of the inequality, we're going to use one of these four symbols, either this symbol or that symbol. This is less than, greater than, less than or equal to, greater than or equal to. We're going to use one of these four symbols, right? And of course, with the line underneath, that means or equal to, okay? Now, it's an inequality. I got to decide, okay, if I have $10 and would I say that the amount that I can spend is less than $10? Would I say the amount that I can spend is more than $10? Or would I say the amount that I can spend is less than or equal to $10? Or would I say the amount that I can spend is less than or equal to 10? Wait, I wrote the same thing twice. Excuse me. What I should have did this. I was working too fast. All right. Should I say that the amount I have to spend is greater than or equal to $10? All right. I got to figure that out. Because if I only have $10, I can't spend more than $10, right? So if I can't spend more than $10, then I can't use that. And if I can't use that, I definitely can't use that, right? Because this means that this amount over here that I'm going to spend is going to be greater than $10. And I don't have more than $10. I only have $10. That's it. This is like real life. When you have $10, you got $10. You can't go above and beyond the $10 because that's what you really have, just $10. All right. So then that rules out this symbol and this symbol right here. So it's got to be one of these two. Now, I could spend less than $10, but I want to find out the possible number of games. So that means like the maximum. What's the maximum number of games I can play? So I can spend up to $10. But if I put less than $10, that means I'm not spending up to $10. I might spend up to $9.99, but I have $10 to spend. So that means I'm going to rule this symbol out too. And I'm going to use this symbol right here. Less than or equal to $10, right? Less than or equal to $10. All right? That would be the inequality. So the amount of money I spend can be less than or equal to $10. Right? Because that shows all the possibilities. All the possibilities. And this says the possible number of games. Okay? Now, if I know that I go to the carnival, how much money do I have to spend? I know I got to spend $3 to get in. So I'm going to write down a 3. And then see this word and? I should have underlined that too. This word and is really important. This word and represents addition because math is a language in and of itself. And many times we have to read a problem in the English language or in any language. It could be Swahili, could be in Tree, could be in the Yoruba language, right? And we have to translate it to a mathematical language, right? So we have the word and that represents a plus sign. And then the number of games I play, right? Or how much money I spend on games. How much money do I spend on games? Now, if one game costs 25 cents, right? Then I would just spend 25 cents on games. But I don't know how many games I could play. That's the whole purpose of doing this problem, to figure out how many games I could play, right? And I'll let the variable G represent the number of games I could play, right? So what I'm going to do is I'm going to say, well, 25 cents times G, or 25 cents times the number of games I play, is going to tell me how much money I can spend on games. So I write 0.25 G. And then, remember we did the work over here, that is less than or equal to $10. So just to recap, this is our inequality. Just to recap, the $3 you pay to get in, which came from right here, $3 admission, and plus sign, because we're adding all this money up, right? 25 cents times the number of games I play, because each game costs 25 cents. So 0.25 G is less than or equal to 10. Less than or equal to 10, right? I only have $10 to spend. I can't spend more than $10. I don't have $11. I don't have $12. I don't have $25. All I have is $10. So I'm either spend less than $10 or at a maximum $10. So at most $10. So when you see this symbol, less than or equal to means at most or cannot exceed. Okay? Now, this is my inequality. We have written the inequality, so we did that part. Now the only other part we got to do is we have to actually solve the inequality. So we'll be able to actually answer the question and know how many games can we play. All right, so we solve the inequality basically the same way we solve an equation, right? With one minor difference that we actually aren't even going to encounter in this problem. So first thing I want to do is I want to isolate, well, ultimately I want to isolate G. Since I want to isolate G, I have to get rid of these other two things on this side of the inequality. 0.25 has to go. This 3 has to go. So you might ask yourself, well, what do I get rid of first? I'm not going to get rid of them at the same time. You get rid of them one at a time. I'm going to get rid of the 3 first because that's further away from the G, right? I mean, I could get rid of 0.25 first, but typically when you do that, that makes the problem more messy, makes the math more difficult. You can do it, but I just don't advise it because we want to work smarter, make the problem as easy as it possibly can be. So I get rid of the 3. How do I get rid of the 3? I see that this is a positive 3. There's no negative sign in front of it. It's a positive 3. Whenever I want to get rid of something in an equation or an inequality, I do the opposite operation. The opposite of a positive 3 is a negative 3, which means I subtract 3. So that means I do this right here, minus 3. And then whatever I do on the left side, I got to also do on the right side. So I do minus 3 over here. So 3 minus 3, that's gone. 10 minus 3, that's 7. This comes straight down. Haven't done anything with it yet. Now I'm getting closer to getting G by itself. I got rid of the 3. Now I'm going to get rid of the 0.25 or the 25 cent, right? Now, how do I do that? Again, the opposite operation. Opposite from what though? Whatever 0.25 is doing. 0.25 G means 0.25 times G. Multiplication. That's what it means. So the opposite of multiplication is division. That means I'm going to divide by 0.25 on both sides. Not just on one side, but on both sides. Right? Boom, boom. Now, only difference between equations and inequalities, if I was dividing by a negative, this inequality sign would flip around. It will flip around. But because I'm dividing by a positive on both sides, it stays the same. Now, 7 divided by 0.25. 0.25 is a quarter. So basically, when we do division, what we're asking is, okay, how many quarters are in $7? Or if I divide $7 up into quarters, how many quarters would I have? Right? I would have 28 because there's 4 quarters in $1 and I got $7. So those 4 quarters in $1 multiplied by 7, that's 28. That's why we have to know our multiplication facts. 7 times 4 is 28. So what does this mean? This means that at most, I can play 28 games because the 28 games will cost me $7. The 28 games will cost me $7. And if I only had $10, I spent $7 on games and I spent $3 for admission. So 7 plus 3 is 10, and that's my $10. So that's the most possible number of games that you can afford in this scenario. If you only had $10, you could afford to play 28 games. And this is, like I said, this is like real life math. This is economics. That's what this is. This is the foundation of economics. Like I have limited resources, but how can I get to do what I want to do or get what I need, right, with those limited resources in the most efficient way, right? Because if you don't know how to do the math, you might just guess and say, well, you know what? I don't know. I think I could probably play 8 games or whatever. And then you plan to play all these games, but then not knowing how much money you actually have that can support you playing all these games, you can run into some trouble. All right. So I hope that helped. Hope that made sense to you. Hope you learned something new. If you haven't subscribed to the page, please subscribe to the page. Share the video. Send it out. Let everybody know about it. Make the video go viral. All right. And as always, before I shut the video down, before I end this video, always remember that there's all this math all around you, just like in this type of problem.